Okay, this is problem number 6 for my Calculus 1 extreme values of functions. It's for our inflection points and critical points curve sketching lab. So again, here's my function. It's f of x equals 8x squared minus 2x to the fourth, which is a polynomial. Over here, I kind of set up what the graph would look like. I set up my f prime bar, my f double prime bar. I did graph this as well, so I'll show you that in a minute. Here's my critical points, a spot for that, my inflection points, my y-intercept, which is 0 in number, and when I put 0 in there, I get 0, so it's the origin. And then I check for my horizontal asymptote and my vertical asymptote, and vertical asymptote is a denominator equals 0. It's not a rational function, so there is none. The horizontal asymptote, I need to know the numerator and the denominator, and there is none. So I kind of filled that off the bat because it was a polynomial. So this is where I got the sketch from. I actually graphed it ahead of time, and I kind of set my window from -5 up to 10. It fit quite nicely, and so it looks like it does cross at 0, 0, and then there's a little sketch of my graph. So I sketched it first, and then we're going to use calculus to determine our critical points and our inflection points. So the first thing I'm going to do is take my function and do the first derivative, and when I do, I get 16x minus 8x cubed. Put that equal to 0 to determine our, because the slope is 0, is our maxes and our mins of our graph. And then I'm going to factor out an 8x out of those terms. And when I do, I get 2 minus x squared equals 0. Make my big T. So 8x equals 0, x equals 0. And we already found out that that was the point 0, 0. And then I got 2 minus x squared equals 0. X squared equals 2. Take the square root of both sides. X is going to equal plus or minus radical 2. Okay, so let's kind of put that. So that's going to be radical 2 something. And when I plug in radical 2, I get 8. When I plug in negative radical 2 in my graph, I get an 8 as well. So here's my 3 critical points. So I'm actually going to first of all do it here. So here, whoops. So here's my 0. And then radical 2, I'm going to put it kind of underneath the hump here. So this is radical 2. Here's negative radical 2 where the slopes are 0. And then I'm going to look at the plus and minuses. So I always look at the factored form, or you can plug it in your calculator. So if I go to the left of a negative radical 2, I get a positive number. So the slopes are positive. Go between that and 0, I get negatives. Between 0 and radical 2, I get positives. And then when it's greater than -2, I get negatives. So make sure that you check that out. We'll do the first derivative test. So if it's positive and negative here, this is a local max. It's a negative and then positive, so this is a min. Positive then negative, this is a max. And our graph kind of looks that way. So let's kind of fill these in. So my critical points, we've already found to be 0, 0, which we said was a local min, a local minimum. And then negative radical 2, 8, and positive radical 2, 8 are both local maxes. So those are our local max. Okay, so we did our critical points. Next is we're going to take this first derivative. I'm going to do the second derivative. So let's do this. So the second derivative of that would be 16 minus 24 x squared, put it equal to 0. Okay, and then I'm going to do 24x squared equals 16. Divide both sides by 24 and reduce it down. X squared equals 2/3. So x, take the square root, is going to be plus or minus the square root of 2/3. Okay, so these are our inflection points. And the radical 2/3 is going to be right in here. So here's negative radical 2/3 and positive radical 2/3 right here for our inflection points. When I put those in my calculator, I get radical 2/3, and it comes out to be 4.44. And also the negative is the same. Negative radical 2/3 is 4.44. So these are our inflection points. So let's stick them over here. I just like everything listed nice and neat down here on the side. Then everything's in one spot, and it makes it a lot easier when you're doing your quiz. So there we've got our inflection points. So the only thing I haven't done is kind of fill in where it's concave up and down. So I'm going to use this again, the factored form, or this form right here. If I go to the left, we'll say like a -3. When I square it, that turns positive. So this is a larger negative number. So I've done this so many times. This is negative. In between here, like if we did a 0 here, this would be positive here, and then it's going to be negative here when I go here. So this is increasing. I didn't do that here. Increasing, decreasing, increasing, decreasing. Here it's concave down. Concave down like a frown. See if I can get that in there. And so is this, and this is going to be concave up, concave down. And if I look at my graph, that's what everything looks like. So I used calculus to justify, did the first derivative test, did my f prime and f double prime bar, listed all my critical points, inflection points, and all that. So I hope that helped. A couple more videos coming, guys.